Okay, my name is Gregory Monda. I work with MEWASSCO. I'm in charge of NRW and GIS. Today we are here in Naivasha, showcasing how we have been able to manage our NRW in a way that we have been recognized as the first utility in terms of NRW management in Kenya. This is our booth. We have the items here which we normally use for leakage detection, to search for leaks in our network. On top of the table where the meter is showing how we do the custom installations to showcase the quality materials which we normally use to avoid incidences where we have faults and water loss in our system. Then in the dashboard is showing how over the financial year for 2025-26 how we have been able to manage our NRW to be at 19%. Okay. It has been easy. It has been a long journey where that we have a very dedicated team for searching for these leakages, and we have another team for operation and maintenance, where they do now the maintenance work and respond faster to these leakages so that we can be able to reduce the leakages in our systems. Kuna kitu kingine nafaa kuongeza from hapo 90% and nieleza that part. Okay, for easier management of NRW, we have to be maintain the data in a way that for each and every month we are able to monitor where we are in terms of NRW. As per our display here, it shows each and every month how the trend is in terms of NRW, whereby by May this year, last month but one, we were able to reduce the NRW from 32 to 20, but when you get the average of it from July last year, we are able to maintain the 19.57, that's 19.6%, which is for us is a huge achievement. But we are not relaxing there. We are focusing on how by next financial year, the end of the next financial year, be able to reach at least 16%. That's our target for this financial year, which is starting today, for 2026-2027 financial year. So these items we are showcasing here are for leakage detection. Hizi ndio tunatumia kutafuta where those leakages are, especially zile leakages ziko under pavements na ziko underground mali hazionekani. So like this, the device is able to identify the precise point where that leakage is, so that we can be able to narrow down the precise point to expose the leakage. Then hii nayo ni ya kufanya flow measurement. For the flow measurement, we usually do it at night when there is a minimal use of water. We call it night flow. We do a step test where you use the device to check on the usage at night. When we expect little or no consumption, hii ndio tunatumia so that we can be able now to see the flow, how the flows are. If the flows are high, then it shows that there could be either illegal water use, or could be there's a leakage which we are not able now to identify from the physical patrolling which you normally do day to day. Then this pipe shows the quality of the materials which we have been able to maintain, so that we maintain the quality of materials to reduce the incidences of pipe faults or equipment faults, and that reduces the water losses. The water losses by reducing the number of incidences where we have faults in our systems. So what in a nutshell, what we are trying to demonstrate here are the quality materials which we have been able to maintain and still continue to use in order to reduce any physical losses in our systems in terms of leakages. This device here is a pressure gauge. This is an analog pressure gauge which you normally install in our pipelines. What it records the minimum pressure, the running pressure, and the maximum pressure, those three. Then we have a digital modernized, this is the modern pressure logger. So this pressure logger, what it does, it records over time the pressure variations, and the data it produces, you are able now to project and do analysis, whereby it shows you the trend of the pressures, how the pressure variations are in a particular area where we will be doing that pressure measurements. So what we have here is the dashboard, is NRW dashboard for our utility, whereby this is the dashboard which is supposed to display information which is displayed in the technical department, the technical manager in charge of the technical department, the finance manager for the finance, and even the MD office. So it's supposed to display so that they can be able to see the trend of NRW. It's not just the NRW, but even the amount being supplied to the customers. Is it purple or multiple? Yes. You see the purple is showing the water supplied to the customers. Then the greenish color shows you the water used for backwash. By backwash, I mean the water being used to clean the systems, which normally treat the water. We normally do the washing of those facilities, and we also account for that water which we use for cleaning. Then the blue shows the amount which we have been able to bill from the supplied volume. So the difference between the purple and the blue tells you about the loss for that particular month. As per the graph, it shows you for a particular financial year. Like for instance, this one shows you for financial year 2025-2026, whereby it shows the trend, the way we started from July 17, then we were able even to hit, by August we hit the 15%. Over the financial year, that's how the graph is. And for this particular, for the month of May, we are at 20. We are yet to analyze for June so that we can be able to know for the month of June where we are in terms of NRW. So for this one, we don't just monitor NRW, we also check the yellow one shows you the estimated bills, which normally affect the commercial losses. So the yellow one shows you how in terms of numbers, the number of connections which have been estimated in terms of billing. So our policy, we are supposed to have 5% of 5% of our connections of our accounts being estimated bills. But as per the graph, you're saying at times we reach 20, other times we are above 20, but we're still working on it so that we can be able now to reduce the number of estimated bills to 5%, whereby we have introduced an application for the customers for the meters which we are unable to read. The customers can be able to remit those readings using that particular app. This other table here, we have DMAs. The whole supply area has been divided into these DMAs, whereby we evaluate each and every DMA by its own. And the trend here shows you how the variance is in terms of NRW. The red one shows the DMAs which have a rise in terms of NRW, and this rise is by how much? It shows you by how much. By looking at it, you can see for instance, that particular zone called Zone 4 Upper Southern is the one which was supposed to be given priority. This data is for the month of May. So coming June, we gave for APA priority in terms of investigating why these losses are so huge in that particular zone. So when it comes to June, we are able now to analyze if we are able to achieve our efforts to reduce on this huge variance in terms of NRW. So we prioritize according to the variance. The one which has a higher variance, we give it the first priority. We have a map here which we call a leakage pattern map. This one is able to give you a live and a pictorial representation of how the leakages have been distributed in the supply network, so that you can be able now, by the look of it, you can see where the concentration of the faults are. By looking at the map and seeing where the concentration are, that's where we used to focus on. This one is supposed to tally with that other trend. The trend table is supposed to tally with this map. By this, it shows where the concentrations of the faults are, and we are able now to prioritize on those particular areas. This graph shows you which zones have. We have ID'd our leakages, where we have a major burst as number 5. We're given the index 5. We have 4, 3, 2, 1 based on those indices. And this graph shows according to the ID of that particular leakage. It shows you which zone has a high leakage based on a particular leakage ID. The zone which has a high leakage ID like 5 or 4, like for instance zone 2, if I put a cursor here from the laptop, is able to tell me which zone is this. We are able even now to concentrate on those particular zones which are recording, because this data is live. As patrollers are out there capturing the leakages, they appear on this map automatically. It's synchronized with their phones. So this data is live. As we collect the leakages, they do appear here. So we use the graph to narrow on which zones are these which are supposed to give priority.